Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture lecture series on Sunday, June 8th at the JFK Auditorium, New St. Augustine, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind address the theme, crossing new frontiers to conquer today's challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, New St. Augustine.
In supercomputing, the grand challenge is a problem that traverses the frontiers of the fields of mathematics, physics, and computer science. The grand challenge is a problem such as global warming that is defined by the public, or a question that society wants to be answered now. In my supercomputing quest for how to solve the grand challenge problem, I discovered how to lift calculus out of the blackboard and into the motherboard and across a new internet that I visualized as a new global network of processors that is a new computer de facto. I discovered how to lift calculus out of the mathematics textbook or the WAEC and JAMB examinations, and how to put calculus into the mile-deep oil fields that each occupy the space of a town in the Niger Delta region of southeastern Nigeria. As a research supercomputer scientist, I see myself as a hunter or a predator, and my prey is the unknown. My quest is to know something nobody else knows. Back in 1989, the foremost vector supercomputer scientists couldn't understand how I parallel processed across a new internet that is a new global network of 65,536 tightly coupled and identical processors. They couldn't understand how I was able to harness that new internet and use that new technology to record the highest speed increase of a factor of 65,536 and record the fastest supercomputer speed that made the news headlines. At first, my massively parallel processed supercomputer experimental results of the 4th of July was rejected as a quote-unquote terrible mistake. After 2 months of rejections, and on September 1, 1989, I took my discovery of practical parallel supercomputing to a 15-day hands-on vector supercomputing workshop that took place in the largest national laboratory in the Midwest region of the United States. That national lab was in Chicago, Illinois. I was invited to Chicago because the parallel supercomputer could become the enabling technology that must be harnessed when applying the computation-intensive mathematical physics that must be used to foresee natural hazards that threaten lives and livelihoods, as well as foresee long-term hazards such as global warming that threatens the health of planet Earth. The parallel supercomputer is the vital technology that must be used to supply timely, relevant, and useful information about the global motions of the fluids that enshroud planet Earth. The extraordinary importance of that supercomputer hopeful was the reason I was invited to the supercomputer workshop that was sponsored by the United States Department of Energy and that was held in the 15 days inclusive of September 1 to 15, 1989. On my first day at that supercomputer workshop, I was mocked and ridiculed because I claimed that I could parallel process across a new internet, that is a new global network of 65,536 commodity processors that were identical to each other. I was offhandedly dismissed because I also claimed that I recorded the highest parallel processed speed increase. I recorded the fastest supercomputer speed in 1989, and I did so when everybody said that my speed was impossible to attain across the slowest processors in the world. But as that supercomputer workshop progressed, the supercomputer instructors learned that I had been supercomputing since June 20, 1974 in Corvallis, Oregon. They learned that I knew more about the parallel supercomputer than any supercomputer scientist knew. At that workshop, I gained credibility as an expert in parallel supercomputing. With each day that passed, I noticed that I was getting fewer and fewer mockeries of my parallel supercomputer discovery. By the 15th and last day of that supercomputer workshop, the majority of the attendees became convinced that I had achieved a breakthrough in parallel supercomputing. Yet, the few naysayers at that 15-day workshop taunted me to submit my parallel supercomputer calculations to the 4 supercomputer scientists and judges that award the top prize in the field of supercomputing. 5 months later, one of those naysayers called to congratulate me after he read the story about the African supercomputer genius that won top US prize.
Insightful and brilliant lecture.